lesson 7.7, we are going to look at operations on functions and also what's called composition of functions. First thing we'll look at is operations here. You have to understand notation. So we're going to have basically the four different operations in math: sum, difference, product, and quotient. And these are just some real simple examples that we're talking about here, and then we'll get into some more complex ones. But let's look at a sum first. Okay. You're used to seeing you're used to seeing functional notation, f of x, g of x, things like that. Well, now what they're going to do is we're going to look at two functions, and they're going to have something that looks like that: f plus g in parentheses of x. That means I add the two functions. I take f of x and I add g of x. I'm going to add the two functions together. So let's look at this simple example that they did here. Here are the two functions. There's f of x, there's g of x. F of x is x plus 2, g of x is 3x. So we do x plus 2. Now they put parentheses around it. You don't really need to put parentheses around it. And then we add 3x. So really what we have there is x plus 2 plus 3x, and I usually do it without parentheses. These two right here are like terms. That gives me, I put them together, because you're going to simplify the expression, which means combine like terms. So x plus 3x is 4x, and then we just have this plus 2 on there. So we added those two together, and that would be adding them. Now, difference means, and here's going to be the notation for that, obviously there's a subtraction sign. I'm going to take f of x and subtract g of x. So they take f of x, which is x plus 2, and we subtract g of x, which is 3x. And again, they put the like terms together, so putting x minus 3x together gives me negative 2x, and then we have the plus 2. One thing I want to talk about, just to change this example up, what if they said g of x, what if it was g of x, so g minus f of x? Well, that means take g of x and subtract f of x. If I do that, I'm going to take the 3x and I'm going to subtract off x plus 2. Now, this is where you got to be careful. Do you see how that f function had two terms? So then you have to use parentheses and distribute your opposite sign. So it's 3x minus x minus 2, which would be 2x minus 2. So just be careful. If you're subtracting a function that has more than one term, put it in parentheses, distribute the opposite sign. Product means I'm multiplying, so f dot g of x, so times, take f of x and multiply it by g of x. So here's f of x, x plus 2, multiplied by g of x, 3x. I distribute on this because it's a binomial times a monomial. So if I distribute, I get 3x squared plus 6x. Sometimes you might have binomial times binomial, then you would have to FOIL. If you have a binomial times a trinomial, then you would have to distribute both terms of the binomial to the trinomial, combine like terms. Quotient means I divide. This is the notation we're going to use for it, f over g of x. We take f of x, put it over g of x, and simplify if you can. Now notice here when we do f of x, which is x plus 2, over g of x, which is 3x, I can't do any simplifying. That is a simplified expression. I can't cancel my x's there. We've talked about all those rules. So that is as simplified as you can go. So once again, the operations, but let's take a look at a couple different examples. Again, I kind of have that table of the four different operations with the examples we just did. Given f of x is 3x squared plus 7x, g of x is this right here, find each function. This is, we're adding. So I'm going to take f of x and add on g of x. So let's take f of x, which is 3x squared plus 7x, that's this function right here, and we're going to add. Now when we add, we don't need to use parentheses, so 2x squared minus x minus 1. Now we just combine like terms. So if I combine like terms here, I've got 3x squared plus 2x squared, which is 5x squared. I've got 7x and minus x, which 7x minus 1x is 6x, and then minus 1. So it's 5x squared plus 6x minus 1. So you're just simplifying the expression. Here, subtract, so I'm going to take f of x, subtract off g of x. So let's take a look. We're going to take f of x, which is 3x squared plus 7x. We are going to subtract. Now I want you to notice g of x here has more than one term, so I got to put it in parentheses. 2x squared minus x minus 1. Now what we need to do is distribute our opposite sign there. So these first two terms aren't going to change, but this is going to be minus 2x squared plus x plus 1. Changing each of those to the opposite or distributing the opposite or negative 1 through. Now we combine like terms. 3x squared minus 2x squared is x squared. 7x plus 1x is 8x. And then I have this plus 1 here. So it's x squared plus 8x plus 1. If we go to the next one, given these two functions, here's f of x, here's g of x. 3x squared minus 2x plus 1 for f of x. G of x is x minus 4. This means multiply. I'm going to take f of x, I'm going to multiply it by g of x. So let's take f of x, which is 3x squared minus 2x plus 1. Now that has more than one term. We're going to multiply it by something, put it in parentheses. We're going to multiply it by g of x, which also has more than one term. It's a binomial, x minus 4. Now, this is a binomial times a trinomial. And remember the rules on this that we've already talked about. We're going to distribute our x through, our first term here of our binomial. So let's go ahead and do that. I get 3x cubed minus 2x squared plus x. And then I take my negative 4 and I distribute that through. And so it would be negative 4 times 3x squared is negative 12x squared. Negative 4 times negative 2x is 8x. Negative 4 times 1 is negative 4. Now I combine like terms. I only have one x cubed term, so I'm going to take care of that. X squareds, negative 2x squared, negative 12x squared is negative 14x squared. So I've taken care of those. Now let's go ahead and put our x's together. So I have plus x plus 8x, so 1x plus 8x is 9x, and then minus 4. So I end up with a polynomial, in this case, that has 4 terms. Now we're going to look at f over g of x. That means I take f of x, I divide by g of x. So if I take f of x, 3x squared minus 2x plus 1, I divide that by x minus 4. Now I can't do any simplifying as is. The one thing you do want to check for is see if the top is factorable. Okay, and in this case it's not, but that could be a trinomial that's factorable, and you might have something that's able to be factored and then one of the factors cancels out. This cannot be simplified though in this case. That top is not factored. If you tried 3x and x and then negative 1, negative 1, just if we tried this, the only way would be 3x and x. If I was going to factor the top, they'd have to be negatives, and the only way to get 1 is 1 times 1. Well, that would be minus 4x, would be minus 5x. Well, we have a minus 2x in the middle, so it can't be simplified. So there we looked at the 4 different operations, really using all the algebraic rules. Now we're going to get into composition of functions. And this gets a little tricky here, okay? Basically, composition of functions is going to look something, well, first one we're going to do is we're going to evaluate when it's a relation, and then we'll get into where they're actually algebraic expressions. Okay, a composition of functions is going to look something like this. They're going to give you two functions, and they're going to do something like this. F, and it looks like a little open circle in the middle. Now that's not a dot for times or multiplication like we just did with the operations on functions. That really means, so they usually do f of g of x. That means f of g of x. Okay? When you have this, you always work right to left. And here's what I mean by that with the two functions. If I'm doing f of g of x, I am going to start with g and then do f. Okay, now we don't have a value to stick in, but when I do f of g, when we actually do like f of g of a value, we'll talk about starting with that value in g, but I do g first, then f. So you're going to take what g outputs and put it into f, and you work right to left. That's the key thing you want to remember with composition of functions. Okay, so over here, we're going to do f of g, because that's the first thing they want me to do right here. So again, that means when we're doing f of g, that means start with g, then output of g, or whatever that gets, output of g, and I'll talk about what that means in it. Output of g goes to f. Key things here. We're working right to left. Alright, so, and then we'll do g of f next, which is kind of going the opposite way. So I want to start with g. I want to start with function g. So we're going to do this. And again, f of g means f of g of x. We're starting with function g. So if I look over here, we're starting with g, these ones over here. What is the first domain value or x value in it? If you look at the first, and this is a set of relations, now, or this is a relation, a set of ordered pairs, it's 7. So I want to do this right here, and you got to really follow along as we go through this. I want to do f of g of my first x value in g, which is 7. Okay? Now, what does this mean? G of 7 means when the x value of g is 7, what's the y value? If you look at that right here, the y value, when the x value is 7, is 0. So I want to then come over here. So that's the output value for an x value of 0 in function g. I want to come over here then and find in g which one has an x value of 0. That output value from g, 0, is going to be the input value into f. Okay? So that really means f of 0. So now that's really the x. And that outputs, as you can see right here, a -1. So, in effect, what did we do? We inputted a 7. That's this value. And we outputted a -1. So I'm going to write it as a coordinate. So f of g of 7 outputted -1. Now we go to the next one. Let me switch back to the color black here. So f of g of what? Now we go to the next x, and again, this is f of g of x, so we go to the next x value here, which is -1. Now, what is g of -1? Well, it's the output value or the range value that goes with the domain or x value of -1. It's 7. So we're then really finding f of g of a -1 here is 7, because -1 gave a range value of 7. Now I come over here and I find 7. We'll talk about what happens if there isn't one over there of that value, but 7 and 7 goes to a 7. So in effect, the coordinate would be, what value did I stick into g first? -1. That outputted a 7. So f of g of -1 is a 7. -1 went to 7 in g, 7 goes to 7 in f, so we went from -1 to 7. Now I'm going to do f of g of, go to your next x value, which is 4. Now, g of 4, well, when the x value in g is 4, the y value is 9. So g of 4 is 9. So this g of 4 really means 9, so we're doing then f of g of, or f of 9. So if I follow that over here, where does 9 go? 9 is right there, and it outputs a 4. So when we inputted a 4, we outputted a 4. So there would be f of g of 4. Let's go to the next one. F of g of, so I'm taking all my x values in g here, because we're starting with g, working right to left. Now I do 8. So f of g of 8. 8 goes to 2, so then I want to come over here, and I want to find 2 over here. So notice 2 is right here. So that's really f of 2, because g of 8 was 2, because 8 went with 2 in function g. And notice the output value there is 6. So if we think of that as an ordered pair, 8 went into g, and then we took that output into f, and it came up with 6. So these would be the ordered pairs in f of g. And you probably should write them in set braces like a relation, but that would be the ordered pairs. Now we're going to go the other way. So what I'm going to do is I'm going to erase all this stuff up here. Otherwise it's going to get too messy. So I'm going to erase all of this. And now I want to think of going the other way. So I want to do, we're going to kind of change gears here. Now I want to do g of f. So here's what I mean, g of f. That really means g of f of x. That means start with f, and then do g second, or go to g second. We're working right to left. So if I'm doing g of f of x, you got to really just follow the path here. So we're going to start with g of f of what is the first x value in function f. So if I go to function f, the first x value in my relation is 2. Everybody see that right here? That's 2. So that's the first one I want to start with. Now we go then to, that would be g of, now what is f of 2? Well, 2 in this first function, that domain value or x value went with, or gave a range value of 6. So now I go over, 2 outputted a 6. So I go, okay, now I got to go over to this function and find a 6 in my x values. If I look at all those x values over there in function g, I have a 7, a negative 1, a 4, and an 8. There isn't one. Okay? G of 6 equals nothing, so that is undefined. We're not going to have an ordered pair because there was no x value of 6. Let's go to the next one. G of f of, go to the next x value in f. We're starting with f, which is 9. So that's g of what? F of 9. So f of 9, 9 outputted a 4. So I want to come over here now and I want to find a 4. Well, there is a 4. It's right here. And that outputs a 9. So, whoops, that's g of 4. When 9 outputted a 4. And then when I came over here to g of 4 is 9. So what ordered pair was that? Well, 9 went in to the first function. Outputted a 4, 4 outputted a 9, so it's 9, 9. Then I'm going to do g of f of, what's the next x value? 7. So that's g of f of 7 is a 7. So I come over here, I look for a 7. There's a 7 right here in the first spot. It outputs a 0. So 7 went in, outputted a 0. And the last one, g of f of, my last x value in f is 0. That outputs 0 outputs a -1, so g of -1. And -1, if I come over here, there is a -1. That outputs a 7. So 0 went in, outputted a 7. So these three would be in the g of f composition of functions. And we'll continue with part 2 of the video to finish up.